Tree injection, also known as trunk or stem injection, is a method of target-precise application of pesticides, plant resistance activators, and fertilizers into the xylem vascular tissue of a tree with the purpose of protecting the tree from pests or nutrition for correction of nutrient deficiencies. Tree injection is currently the most popular method for control of damaging insects, pathogens, and nematodes in landscape tree care. It has been developed primarily for use on large-sized trees and in proximity of urban areas where ground and air spray applications are impractical due to substantial drift-driven pesticide losses or not allowed due to potential human exposure. However, the prime driver of tree injection use has been a widespread need for control of many invasive tree pathogens and insects pests. The most infamous examples are that of Ophiostoma fungi that cause Dutch elm disease, DED, and insect emerald ash borer, Agrilis planipennis, which have specific biologies that lead to severe internal damage of wood and thus tree death, and which make their management extremely difficult or inefficient with classical pesticide application methods. Trunk injection for tree protection is viewed as environmentally safer alternative for pesticide application since the compound is delivered within the tree, thus allowing for selective exposure to plant pests. In landscapes and urban zones, trunk injection significantly reduces the non-target exposure of water, soil, air, and wildlife to pesticides and fertilizers. In the last 20 years, tree injection is gaining momentum with the development and availability of new, efficient injection devices and injectable and xylem-mobile formulations of pesticides, biopesticides, and nutrients. Further, a number of newly occurring and fast-spreading invasive insect pests and diseases such as Polyphagus shothole borer, PSHB, Yawalaceae sp, which vectors plant pathogenic fungus Fusarium yawalaceae, and sudden oak death, SOD, caused by Anumiceae Phytophthora ramarum, establish the use of trunk injection as the most efficient tree protection technique in landscapes and urban forestry. In the past and recently, trunk injection of pesticides and plant resistance activators has been investigated in agriculture for control of pathogens and insect pests on fruit tree crops and grapevines. The most investigated are diseases and pests of avocado, apple, and grapevine, such as Phytophthora root rot of avocado, Phytophthora cinnamomum, and avocado thrips Cyrtothrips persea, fire blight Erwinia amylivora, and apple scab Venturia inequalis, oblique banded leaf roller Coristonura rosaceana, and codling moth Cedia pomonella, and grapevine downy mildew Plasmopara viticola, and powdery mildew Uncinula nicator. Apple trees are especially interesting as a research model in agriculture since it is known that apple production requires intensive spray schedules for control of pathogenic fungus V. inequalis with as many as 15 to 22 sprays of fungicides per season in humid climate. Hence, trunk injection of pesticides is considered as an option for precise compound delivery which will reduce the negative impact of drift-driven pesticide losses in the environment that occur after each spraying. Besides negative consequences of frequent pesticide applications in the environment, stem injection of grapevines is investigated in viticulture for control of pathogens with difficult biologies which infect and destroy woody tissues and that cannot be controlled efficiently by canopy spray applications of fungicides. To increase the efficiency of injected compounds in trees and vines, important considerations are plant anatomy, weather and soil conditions, tree physiology processes, spatial and temporal distribution of injected compound, and the chemical properties of injected compound and formulation.